Welcome to Summarize Science. Today, we are looking at a clever new trick astronomers are using with the James Webb Space Telescope, detailed in a study they call JADES Dark Horse. Normally, when using Webb's NIR spec instrument, astronomers are careful to observe only a few hundred galaxies at a time to avoid their light from overlapping, as shown by the red targets here. But the Dark Horse team threw that rulebook out. As you can see from the far denser blue targets, they packed the instrument by deliberately observing over 850 faint, distant galaxies all at once. This unconventional approach creates a bit more background noise, like more chatter in a crowded room. But the trade-off is huge. They increase their survey speed by a factor of 5. This chart illustrates the gain in efficiency, showing they can get far more data for the same amount of telescope time. And the results were incredible. In a single observation, they successfully measured the precise distance to over 540 galaxies, some from when the universe was extremely young. This plot shows that despite the extra noise, the quality or sensitivity of their data is still very comparable to much slower, traditional methods. The goal was to get a massive census of galaxies in the early universe. They wanted to measure how fast these galaxies were forming stars, what they were made of, and even find rare objects like supermassive black holes. This powerful method can also be used in very creative ways. For example, the researchers used a very distant galaxy, labeled here as 634,005, as a kind of backlight. The light from this galaxy passed through the gassy halo of a closer galaxy, LS 010.1, revealing hidden dust nearly 20,000 light-years away from it. Because they can observe so many galaxies in one patch of sky, the technique is perfect for finding ancient cosmic structures. Here, they identified a massive overdensity, or protocluster, of galaxies from when the universe was less than 1 billion years old. The single dark horse pointing, outlined in purple, found 13 members of this cluster, including 6 that were previously unknown. So how does this stack up against other ways of using Webb? This figure compares the dark horse method to another technique for observing many objects. For the same amount of survey time, dark horse is vastly more sensitive, able to see much fainter signals. This makes it up to 100 times more efficient in terms of the total exposure time needed for the same result. So, let's recap the key points. The dark horse method deliberately overlaps hundreds of galaxy spectra to observe them 4 to 5 times faster than usual. This comes with a small, manageable penalty in noise, but the massive gain in speed is more than worth it. It's a revolutionary approach that provides a compelling middle ground between the completeness of wide surveys and the sensitivity of deep ones. What this ultimately means is that astronomers can now build enormous catalogs of the universe's earliest galaxies much, much more quickly. This will accelerate our understanding of how the first stars and galaxies formed and evolved. It's a perfect example of scientists finding innovative ways to get the absolute most out of an incredible tool like the James Webb Space Telescope.